Now let's discuss what is work transfer. Now work is one of the basic modes of energy transfer. If you talk about mechanics, in mechanics the action of a force on a moving body is identified as work. So if you have a body, alright, and if you apply a force onto this, and what happens is that it changes its position, it gets displaced. So we can say that some work is done. So this is work being done on this body with the help of this force. But a force never produces a physical effect except when coupled with motion, and hence it is not a form of energy. An effect such as the raising of a weight through a certain distance can be performed by using a very small force through a large distance, or a large force through a small distance. Okay, and the product of force and distance is the same to accomplish the same effect. So in mechanics, the work is defined as the force as it acts upon a body moving in the direction of the force. So this is what the definition of force is in mechanics. That is, that when a force acts on a body and it moves in the direction of the force applied, then we say that a certain amount of work is done. Now, in thermodynamics, the work transfer is considered as occurring between the system and the surroundings. So if you talk about, let us say this is my system, alright, and the outer part are my surroundings. So the work transfer happens across the system boundary. So either the work is happening, or the work transfer is from the system, or this is from the system and this is to the system. Alright, so this is what happens in the case of thermodynamics. So if you talk about that the work, let me define a system again, that this is my system. Alright, so this is the system. So if the work is done by the system, so this is work from the system or work by the system on the surroundings, then we say that the work done is positive. Okay, but if on the other hand, and this is my system, and now the surrounding has to perform some work on the system, so this is work on the system from the surroundings, then this work is taken to be negative. Now why do we take it to be positive and why do we take this to be negative? Now see, to understand this, just assume system to be your servant. Okay, now ideally what should happen? The servant should work for you. So if a servant works for you, you're happy. So system working for surrounding, everybody is happy, so work is positive. But if you have to work for your servant, something is wrong. You're not happy. So this is negative. So when surrounding works on the system, the work is taken to be negative. So that is why, so this is how, not why, but this is how you can actually remember and correlate, and logically see that why work is positive and negative in these two cases. Now let's talk about, the most important type of work in thermodynamics that we call the PDV work or displacement work. Alright, so now, and to understand these terms, that is PDV work or displacement work, let's have a look at this diagram. Okay, so what we are looking at is a piston cylinder arrangement with some gas inside it. Alright, so this is state 1 with pressure P1 and volume V1. And right now the system is under thermodynamic equilibrium. Nothing is happening mechanically, chemically or thermally. The system is under thermodynamic equilibrium. Now what happens is, the gas which is exerting pressure on this side of the piston, let us say some imbalance exists, and the piston now moves from this position to this position. So this is the new position. So gas expands. Alright, so this is state 2. and in state 2 the pressure is P2 and the volume is V2. So now the gas has expanded and the piston has displaced its position through a distance, let us say dl. So this is the elementary distance through which the piston moves as the gas expands. Okay, now what is the force that is being exerted? The force is, let us say, F. So this is the pressure force. Alright, that is exerted on the piston by the gas, and the piston moves. Now let us say in moving through this much elementary distance or this much displacement, the amount of work done is dW. So dW is force into displacement, isn't it? Now what is force? Now this force is the pressure force, and let us say for this much amount of elementary displacement, the pressure force is P into the area of the piston, and this is dl. Now what is area into the length? That is the volume. So this means this becomes P into dV. So dV is the volume that is displaced in moving from state 1 to state 2. Okay, so you can say that dV, which is equal to AdL, this is the you can say elementary or infinitesimal displacement volume. So I'll write a easier word, elementary displacement volume. Alright, so this is something that you should understand. Now, the total amount of work done, in from, that is going from position 1 to position 2, in which the volume changes from V1 to V2. Alright, so the work in going from position 1 to position 2, this is equal to integral V1 to V2 into PdV. So this is the PdV work or the displacement work. Alright, a very important point to note down here is that this differential is written as dW, and you have a dash on top of D. Now why is this dash here? We'll talk about it in another video, and this is very important. Alright, so this is the displacement work that we are concerned about, and which we also call as PdV work. Now the magnitude of the work done is given by this, and this can also be applied for a quasi-static process. So let us say this is your PV plot, and let's say this is state 1, and you have a quasi-static process from state 1 to state 2. So this is what happens, and you have the properties P1, V1, and then you have P2, and then you have V2. Alright, so the work done, that is in going from 1 to 2, is the area under this graph. So the value of the work in going from state 1 to state 2 is the area below this graph. So again, this can be written as W1 to 2 integral V1 to V2 into PdV. Now this equation is only applicable to quasi-static processes. But remember this is only applicable to quasi-static processes. So this process that is happening is a quasi-static process, and all the intermediate states that occur are equilibrium states. Alright, so this is a very important concept that you need to understand on the topic of work transfer and the topic of PdV work or displacement work. Now after understanding this, let's move on to a very, very important topic on the same, you can say, subject of work transfer, and discuss what do we understand by path function and point function. So now let's move on to the next video and talk about these two topics.